Ignition sequence start.
Good morning, and welcome in for a look at the activity in the International Space Station Flight Control Room. It's the spot where a team of specialists is always keeping an eye on operation of the space station and working with the Expedition 66 crew members as they move through the business of the day on orbit. Commander Thomas Pesquet and his American, Russian, and Japanese crewmates are poised for a busy next couple of days, anticipating the arrival of a new shipment of supplies in a Russian cargo ship, and then 4 new crewmates arriving in a Crew Dragon vehicle.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Nilofer Ramji. Preparing for a new crew and wrapping up a decade of research. Lots of activity this week aboard the International Space Station. NASA's SpaceX Crew 3 mission is set to launch 4 astronauts to the International Space Station aboard a Falcon 9 rocket. The mission includes 3 NASA astronauts: Mission Commander Raja Shari, Pilot Tom Marshburn, and Mission Specialist Kayla Barron. European Space Agency astronaut Matthias Mauret will also serve as a mission specialist. Crew 3 will be conducting a 6-month science mission aboard the space station. Launch is targeted for 2:21 a.m. Eastern Time on Sunday, October 31st from Space Launch Complex 39A at NASA's Kennedy Space Center in Florida. NASA will provide live coverage of launch and docking activities on NASA TV, the agency's website, and the NASA app. Meanwhile, NASA's SpaceX Crew 2 mission is preparing to come home. The return of Crew 2 with NASA astronauts Shane Kimbrough and Megan MacArthur, Japanese Aerospace Exploration Agency astronaut Aki Hoshide, and European Space Agency astronaut Thomas Pesquet is currently planned for early November, with splashdown of Crew Dragon Endeavour off the coast of Florida.
Space to Ground.
Following over a decade of research aboard the space station, the Light Microscopy module is ready for retirement.
And liftoff of Discovery.
Launched on STS-128 in August 2009, the Light Microscopy Module, or LMM, has contributed to scientific discoveries, including improvements in biomedical device technology, while also improving our understanding behind the phenomena of earthquakes. Through its 40 experiments conducted over 11 years, LMM has been instrumental in helping scientists and engineers understand the forces that control the organization and dynamics of matter at microscopic scales. That's Space to Ground for this week. Thanks so much for watching. We'll see you next week.
The astronauts flying on NASA's SpaceX Crew 3 mission have been working together for months and months now to prepare for their launch and then the 6 months they'll spend together on the International Space Station. You'd think they've gotten to know each other pretty well by now. Well, watch as Raja Shari, Tom Marshburn, Kayla Barron, and Matthias Maurer declare who on their crew is the funniest and who has an annoying habit. Find out which crew member is the most perspicacious and who said smorgasbord and why.
Raja is super fast at analysis.
Funny, caring, and competent.
And he's super talented, super skilled, a lot of fun to work with.
Tom Marshburn, I would say creative and a teacher.
The silent, quiet part, but with a lot of experience.
Wise.
Kayla is a great communicator.
Perspicacious.
So much experience being in confined environment, keeping calm.
Matthias is a constant innovator.
Inventive.
Innovative.
The funniest must be Grinder. That's Raja.
Grinder.
Raja.
Tom's he doesn't talk about it a lot, but he's done a lot of crazy mountain climbing.
Tom Marshburn is the most adventurous.
Good question, Matthias.
I think that would be me.
Primarily looking out the window with each of them individually and just doing stupid human tricks together.
Enjoying the time off work, watching down towards our beautiful planet and just sharing our dream.
Probably hanging out in the cupola and just looking down on the Earth.
I think coming up with some crazy concoctions made up of expired food that we turn into a smorgasbord. I think Kayla might win if we span it out over time because she has the ability to sustain snacks for a very long period of time.
It's like Kayla loves a big breakfast.
Probably me or Grinder, unfortunately.
Probably Kayla.
Kayla.
Probably I don't know, we should have one. Find out.
Probably talking to myself when I'm thinking.
I think I've started having more inner monologues or things I'm saying under my breath that I got from Tom Marshburn.
I should ask them that though. Let me know what they say.
Probably me.
Probably me.
That'd be me.
That's me.
When Rajachari and his crewmates arrive at the International Space Station and join Expedition 66, they'll join an effort that started more than 20 years ago to use the unique environment of microgravity to explore technologies that will help humans explore space farther away from Earth, like going back to the Moon and then out to Mars. In this first episode of Tech on Deck, we learn about NASA's Exploration and In-Space Services Projects Division at the Goddard Space Flight Center, and its work to test technologies designed to usher in an era of more sustainable, affordable, and resilient spaceflight.
Did you know that if you were born after 2000, during your entire life there has been someone living in space? That's thanks to the International Space Station, which celebrated its 20th anniversary of continuous human habitation in 2020. You've probably heard a lot about the incredible science that happens on board the station, but the outside is actually prime real estate for all kinds of experiments and technology development too.
The International Space Station is a great platform to demonstrate service and technology because it provides power, data, there's robotics in space.
With Tech on Deck, we'll be talking about some key experiments that have taken place outside in the harsh environment of space, which will help us advance human exploration.
Nexus is NASA's Exploration and In-Space Services Project Division at the Goddard Space Flight Center. The goal of the division is to usher in a new era of more sustainable, affordable, and resilient spaceflight, both near the Earth, around the Moon, and deep into the solar system. Many members of the Nexus team started off with the Hubble telescope servicing missions. We've taken that technology, applied that to robotic servicing.
From robotic refueling missions that will help spacecraft live longer and journey farther to autonomous navigation systems, NASA's Exploration and In-Space Services Division has taken advantage of the wonderful opportunity station offers to test new technologies. As we look to exploring our solar system and beyond, and establishing a sustained human presence in space beyond low Earth orbit, many of these technologies will play a key role.
We use the robots in Space Station to demonstrate the technologies needed to enable satellite servicing in the future. We've also used the robots on Space Station to do some of the more repetitive tasks or the dangerous tasks that astronauts shouldn't be doing, like going outside the space station to try to look for ammonia leaks. Robots are very good at moving fine, delicate positions, moving back and forth, doing those sorts of tasks that would be challenging for humans to do.
In order to live in space, astronauts will first need to reach their far-out destinations like Mars. This will require refueling and replenishment of oxygen supplies, things the robotic refueling missions worked to demonstrate on station. They will also need to be able to construct, maintain, and repair their habitats, as well as adapt to unforeseen circumstances.
Because we're in space in low Earth orbit, we have lighting conditions that are representative of objects in space, and so allows us to launch tools and modules into orbit, put them on the space station, and then use those robotic technologies and all the infrastructure that comes with the space station to mature those technologies in a way that's much, much less expensive than if we try to launch our own satellite and demonstrate those for the first time, not using the space station.
For these endeavors, Nexus's work with astronaut tools, satellite servicing, and on-orbit assembly and manufacturing will do the trick.
We develop the technologies that are needed to advance exploration in ways you can service satellites in the future, build satellites and build structures on orbit, refuel satellites on the way to other planets, repair those satellites, much like we do on that side of space station. Both humans and robots are used to maintain habitats in space. We're developing technologies that can be used by NASA and others to make those a reality.
The International Space Station is the perfect testing ground for technologies that will be used to propel humans farther than we've ever gone before. The station is helping us build the necessary foundation to make it possible.
The International Space Station is a working laboratory in space, and solar energy is a key element in keeping it running. Astronauts rely on this renewable energy source to power the machines they need for their science work, as well as the ones they need for their survival. In this demonstration video, astronaut Ricky Arnold explains the process of generating power from the station's solar arrays to produce electricity for astronauts as they orbit 250 miles above the Earth's surface.
Hi, welcome aboard the International Space Station. I'm astronaut Ricky Arnold, and I'm currently at one of our human research facilities on ISS, where you can see centrifuges, laptops, and other scientific equipment. Across from me is another one of these experiment racks, where you can see ultrasound imaging, more laptops, cameras, other equipment, all stuff that requires electrical power. In fact, we have so much equipment for science and life support that our electrical system has about 8 miles or 13 kilometers of wiring to make it all work. So where does this energy come from? Let's have a look. From here in the cupola and through other windows, you can easily see the solar arrays soaking in the sunlight. They are massive. These 4 solar arrays are made of solar cells, which are purified chunks of the element silicon. Together, the solar arrays contain a total of 262,400 solar cells and cover an area of about 27,000 square feet, more than half the area of a football field. That's huge. When the station is in sunlight, the solar arrays produce about 60% more power than we actually need during the daytime. That extra power goes directly to charging our lithium-ion batteries. Now, those batteries are essential because they provide the power we need during the 16 night times we have per day here on the space station. The energy our solar arrays can produce is enough to power 40 homes. And we can maximize the power we generate by rotating the arrays in 2 axes, one like a windmill to track the sun through the course of the day, the other to track the sun's inclination, or its angle in the sky. The space station's electrical power system uses direct current to provide energy for our laptops, lights, water recovery system, and science experiments. Thanks for coming aboard today. Now back to Earth.
Lessons from space, like the ones Ricky Arnold and other astronauts have taught, were designed to take advantage of the presence of a former classroom teacher as a member of the International Space Station crew to help students and their teachers on the ground in their studies of science, technology, engineering, and math. It was an effort that was built on the example set by another teacher more than 35 years ago.
Reach for it. Presented by Science at NASA. In August 1984, President Ronald Reagan announced NASA's plan to send one of America's finest, a teacher, to space aboard Space Shuttle Challenger. Of 11,000 aspirants for the adventure, 37-year-old high school teacher Krista McAuliffe from Concord, New Hampshire, was chosen. As the first teacher traveling to space, she planned to conduct science demonstrations from low Earth orbit to get students, quote, excited about history, about the future, and about space, end quote. Tragically, Challenger broke apart soon after liftoff on January 28, 1986. There were no survivors, and McAuliffe's planned demonstrations were shelved. International Space Station astronauts Joe Acaba and Ricky Arnold have brought McAuliffe's mission full circle by completing and filming on orbit her envisioned lessons as a tribute to her legacy. U.S. crew members aboard the station have also performed and captured other brief, engaging lessons, or STEMonstrations. As part of the Year of Education on Station, NASA has made all of the demos available to classrooms around the world. Chromatography is one of the most interesting McAuliffe lessons Akaba and Arnold have brought to life. It provides hands-on activities for students to understand the importance of capillary action and chromatography and compare how they work in microgravity versus on Earth. Capillary action occurs anytime a liquid spontaneously flows into a narrow tube or porous material. It's how plants get water from their roots to their leaves. It's how our blood makes a round trip through our bodies. And it's how those paper towels soaked up the orange juice you spilled this morning. Chromatography is a technique that uses capillary action to separate mixtures so they can be analyzed. On Earth, chromatography is used for activities such as studying samples at a crime scene. Chromatography is an essential technique for spaceflight, too. For instance, keeping crew persons safe from contaminants includes analyzing unknowns, which can be critical on long space missions. An example of a Year of Education STEMonstration features NASA astronaut Randy Bresnik slingshotting objects of all sizes across the inside of the space station with a bungee cord. He's illustrating how Newton's second law of motion holds true in microgravity, just like on Earth. Simply put, Newton's law states that the greater the mass of an object, the more force it will take to accelerate it. Year of Education on Station also included more than 60 opportunities for hundreds of students and teachers to connect via in-flight education downlinks with astronauts aboard the space station for live question and answer sessions. Participants ask questions about all aspects of living and working in space.
Hi, my name is Ramsey, and my question is, have you ever had the idea to get a lot of water, pour it out, and see what happens?
See how it just sticks to my hand? It just waves there. It doesn't really go anywhere. It just sticks right to the surface, so I could drink my lemonade right from my hand.
How do you grow plants in microgravity without soil and water getting everywhere?
One of the plants actually uses pillows that are impregnated with moisture and the nutrients they need. We have another advanced plant habitat that I've been working on where there's a reservoir and the water, it's all very controlled, pretty much soil-free. The important thing is nutrients and water.
Hi, I'm Lexi. Would a yo-yo work in microgravity?
I didn't have a lot of time to practice, so here we go. My first yo-yo. So it works, but it's a little bit different. So thanks for the question and letting me find out if they do work.
With the Year of Education on Station, NASA's goal was to do what Krista and her optimism did so well: inspire students and teachers to, quote, reach for it, push yourself as far as you can, end quote. For more on NASA's Year of Education on Station, go to www.nasa.gov/STEMOnStation. For other inspiring NASA happenings, visit science.nasa.gov.
NASA's Human Research Program is using the International Space Station to learn more about how living in space impacts the human body, so we can figure out how to counteract the negative effects to protect future astronauts when they explore out beyond Earth orbit. And that includes dealing with the radiation that astronauts are exposed to when they're outside the protection of Earth's atmosphere. In this installment of a series on space radiation, HRP scientists discuss the biological risks that future astronauts will face on missions out into the solar system.
So of all the things that the Human Research Program is investigating, the biological consequences of radiation exposure is one of the major ones. Some of the reasons for that is that the health consequences following radiation exposure are very complex processes. It's difficult to quantify exactly how the radiation is interacting with tissue, and then it's even more complicated to try to quantify and determine what the long-term outcomes are going to be in terms of things like carcinogenesis, central nervous system effects, and detriment to the central nervous system.
The primary means by which radiation affects cells is by damaging their DNA. You can get breaks in the strands in the double helix, you can knock bases out, and the cell will make an attempt to repair that damage. Sometimes it's effective, sometimes it's not, and sometimes it'll actually get repaired, but in an error-prone fashion, so it's what we call misrepaired. So anything that sets into the genome in that way is a mutation, and the accumulation of mutations can potentially lead to cancer and take a non-cancerous cell, a normal cell, and make it transformed into a cancerous one, so that's a big concern.
So on Earth, there's a couple characteristic things that are different from space. One of them is that the type of radiation we experience on Earth is generally what we refer to as low LET radiation, things like gamma rays and X-rays. We also have the protective shielding of the Earth's magnetic field and the atmosphere, which shields a great deal of the radiation. And then finally, we have things like radiation protection concepts such as time, shielding, and distance. So we can reduce the time of exposure on Earth, we can reduce the distance from the radiation sources, and we can reduce the exposure through shielding. In space, a lot of those things are very different. So we have a very complex radiation field that includes things like protons and all the particles on the periodic table of elements. They're coming in at energies that are approaching the speed of light, and they're difficult to shield against. And they're always there. So the concept of time really doesn't make sense because you can't reduce the exposure in space except perhaps getting to Mars faster. You can't really reduce the distance at all because the radiation is everywhere. And shielding concepts for galactic cosmic rays are very difficult because of the energies involved.
As you'd imagine, performing science research on the ground can be very different than performing it in space. And many International Space Station crew members who spend time working up there come away feeling like they've undergone a profound change. Former astronaut Jack Fisher is one of them. Here he recalls his time in orbit and discusses how the spirit of exploration contributes to humanity's future.
The bug for space really bit me when I came down to visit my grandpa down here in Houston. So I saw the big old Saturn V rocket sitting on its belly out there and just thought, man, if humanity can do something this amazing, this awesome, I want to be a part of it. And I just fell more in love with the idea of space and being a part of something bigger than myself. The thought of actually getting to space, I couldn't wrap my head around that. You walk up to this rocket that's covered in frost from the cold fuel inside, and it's creaking and groaning and kind of alive, and you're like, well, that's pretty cool, but they're probably gonna cancel. It's just not gonna happen. You know, I've done so many sims, and it just can't be real. There's no way I'm gonna go to space. But then when no kidding, it lights off and you feel the rumble, and then you start to move, and that kind of just constant smooth acceleration, pulling you back in the seat. Everything comes to life on the panels. You see all of the things that you've seen 100 times in sims. In one instant, all of that I felt was unimaginable became real. And it was a magical thing I'll just never forget. You know, we're scientists and engineers and pilots and doctors. We're not poets, but we sure try to be, because you want to share as best you can the experience that you've seen and felt. I think I told my wife once I got on board that I thought it was
It's a burrito of awesomeness smothered in awesome sauce, baby. It's so beautiful.
It was just the beauty of being there yourself with your own eyes and seeing it. One thing that I would love to do while on orbit was there was a window in one of the Russian modules that looked kind of out the back of the station. And I'd go sit there. I'd turn off everything and you could get it really dark in there, let my eyes adjust and just look out at the stars. And the stars, you know, the longer you sit, the more you see, and it becomes unbelievable. The number, the just billions of stars, the Magellanic Clouds, the galaxies that you can see with your naked eye. And they don't twinkle. They just stare at you. They dare you to come and to explore. It lights a fire inside your soul that is unlike anything I ever experienced before or since. And it's why you see astronauts, you know, they say 560, 580, I don't know how many people have gone to space. They're all the same. They all have that bug. And they all want to do everything in their power after experiencing that to make sure that humanity reaches its potential, that we get there, that we don't just see the stars, that we explore them, that we live there, that we grow into what we can be. And you're reminded of the incredible potential that we have as humans when we put everything else aside and just work together. And you feel a part of that, looking out the cupola and just being a part of thousands of people from across this globe that have put together this just palace in the sky for us to discover and learn and grow. It showed me the potential of what humanity can be when you work together as one team. It inspired me to do everything I can in my power for the rest of my life to enable humanity to evolve, to get there, to those stars that were staring straight in my face and daring us to come get them. That is something that you can never quench. It's been a couple years since I flew, and that fire still burns just as strong today as it will when I die.
Want another look at some of the stories we showed you today? Well, you can find them all on YouTube and Facebook at those addresses right there, rubbing shoulders with lots of other great features on a wide variety of NASA topics. If you're looking for good conversation about human spaceflight, check out Houston, We Have a Podcast, our weekly show about all aspects of human spaceflight and NASA's missions of exploration. Today, Gary Jordan talks with each of the Crew 3 astronauts and gets a little insight into their backgrounds and their goals as they get set to leave the planet for 6 months on the space station. Go to nasa.gov/podcasts for this week's episode and all our previous episodes, and the full library of all the NASA podcasts, which are also on Apple Podcasts, Google Podcasts, and SoundCloud.